Okay, so time to talk about the rest of the stuff that you should be familiar with before you show up to class for lesson 3. I want to refamiliarize us with exponential and logarithmic functions, which may or may not have been the bane of your existence a couple of years ago in Algebra 2, but these are definitely things that were covered in some Algebra 2 course and in some place long ago. The exponential function, oh, that is not what we want at all. We'll just keep going. Uh, the exponential function is something that should be familiar to you. Something like this. Y equals 3 to the x that passes through 0, 1, and 1, 3, figure not drawn to scale, and negative 1, 1/3. That should be a familiar function. Equally familiar is the function that looks like this. This is 1/3 to the x, or if you like, 3 to the negative x, and it passes through 0, 1, and negative 1/3, figure not drawn to scale, and 1, 1/3. So those are familiar graphs for you. For both of these, the domain runs through the real numbers. The range is all the positive real numbers. Neither graph touches y equals 0. Both graphs are asymptotic to y equals 0. So these are all functions that we're familiar with. We know how they behave. We even remember all the rules for exponents, where if a is positive and b is positive, then if you have b to the x times b to the y, that's b to the x plus y. And if you have b to the x over b to the y, that's b to the x minus y. And if you have b to the x to the y, that's b to the x y. And if you have ab to the x, that's a to the x, b to the x. And if you have a to the x over b to the x, that's the same as a over b to the x. These are all things that are familiar to us from the Algebra 2. In fact, from Algebra 1, this is familiar to you. These are all things I would expect us to have right on the tip of our tongue all the time. I would also expect us to be able to talk about the number e. The number e is approximately 2.71828182845945 approximately. It's an irrational number. It's decimal decimal expression goes on and on forever and ever without repeating. This is the amount of dollars that you have, the number of dollars that you have if you invest $1 at 100% interest, compounded every moment of every second of every minute for a year. That this is the upper limit of how compounding interest can get you. You can't do better than this. So this is the number E. It's Euler's number. You learned about it in Algebra 2. It meant absolutely nothing to you and probably still doesn't, except that this is the base of the natural logarithm, which doesn't make any sense either because you don't know the stuff that we're going to talk about in this course. This is the course that makes this number matter. Okay? Okay. So because, oh, let's go back. Let's go back to here. This function is 1-to-1. This function passes the horizontal line test all the way up the line. Because this function is 1-to-1, it has an inverse. And that inverse, so let's draw. This is the function y equals 3 to the x. It has an inverse, and that inverse is a log function. Oh, whoa, sorry about that. Let's undo. Undo, yes, thank you. Not trying to scare the viewer. Log of x base 3. Log base 3 of x. The deal with logs. You are aware that if we talk about a log, there's a base involved. Logs are taken with respect to a number, and logs are exponents. There is no difference between writing this and writing this. When we write this statement, we mean that one. When we write that statement, we mean this one. They are equivalent. And because these two functions are inverses, because they are reflections over y equals x, it is true that if you take the log in any base of b to the x, you get x. And if you raise b to the log of x base b, you get x. Why? Because what is this number? This number is the exponent you put on b to get x. So if you take the exponent that you put on b to get x, and you put it on b, you get x. That's the way this works. I should note, thinking still about this slide, that if you write a log base e, that is the same thing as the natural logarithm. This is French. It's la logarithme naturelle. So the adjective follows the noun, and that's why it's an ln and not nl. There are rules involving logs. We should outline them for you. If A and B and C are positive, and B is not 1, and R is a real number, then the following are all true. The log of A times C is the log of A plus the log, oh, mercy sakes alive, plus the log of C. The log of A over C is the log of A minus the log of C. There is no surprise here. When we multiply powers of the same base, we add their exponents. When we divide powers of the same base, we subtract their exponents. There is no surprise there whatsoever. And when we take the log of a to the r, that r comes right down in the front. Nothing unusual here. This is Algebra 2 we are refreshing. We should know how to solve things. We should know how to solve things that look like this. And we should know how to solve things that look like this. I will do both of those for you. This exponent is so high. How do we deal with that? Well, we take the log on both sides. We can take a standard base 10 log. We can take a natural log. It doesn't matter. Any base will do. Because what does that do? This x comes down in the front. That's the power rule from the previous slide. And so x is the log of 2 over the log of 3. Promise me, no one can hear you do this. Promise me that you are never going to cancel those logs. Just promise me that. Say it out loud. Promise me that you're going to leave the answer in that form. Okay. What's happening over here? Well, what does this mean? This means 1 over e to the x. So I don't know how you would deal with that, but I don't like fractions at all. So I'm just going to multiply everybody in sight by e to the x. I can multiply this by e to the x. I can multiply this by e to the x and kick it over. And I can multiply this by e to the x. And what we get is a quadratic equation in e to the x. So looking for numbers that multiply to 4, add to, oh, that's just hideous. This question has no answer. Oh, that's terrible. Rooter, you're live. You are live. Oh, I'm so sorry, people at home. I'm so sorry, world of YouTube. Looking for numbers that multiply to -4 and add to -3. So that's those. Those multiply to -4 and add to -3. So we solve this, or we solve this. We know that the graph of e to the x stays on the positive side of the x-axis at all times. This has no solution. But e to the x equals 4, oh, that's got solution. And that's the natural log of 4. Okay. If you're looking for opportunities to practice with questions that have been vetted by some author somewhere, you want to try these questions. Again, nobody's going to check to see that you did them. Nobody's going to collect them and take a grade. But if you want to ask about these when we gather, these would be the right kinds of questions to ask about. All right, we'll see you in class.